my channel. Today we are talking about congruent triangles. So two triangles are congruent if they have the same side lengths and angle measures. In other words, all of their corresponding parts, which is one of our key vocabulary words we're going to be going over, all of their corresponding parts are congruent. So let me first go over. We have what's called a congruency statement. And the congruency statement tells us not only what triangles are congruent, so triangle ABC is congruent to triangle SUN, for example, but it also tells us which parts on those triangles actually correspond with one another. So an example of a congruency statement would be triangle ABC is congruent to, and this symbol means is congruent to, triangle SUN. And what this tells us is that certain parts on these triangles correspond and are congruent. So what I'm going to do now is actually draw out these two triangles. And make these as congruent looking as possible, but we're just going to assume that they are congruent. So we have A, B, C, and SUN. Okay, so what this congruency statement tells us is, first off, angle A, right here, this angle right here, corresponds and is congruent to angle S. So our order matters here, okay? We also have that angle B corresponds and is congruent to angle U. Now notice, I did one arc for angle A and angle S, and I did two for angle B and angle U. The way that you denote that two parts are congruent on your figure itself is that you use the same exact, symbol. So if they have the same symbol attached to them, it means visually on your diagram, I know that angle B is congruent to angle U, and angle A is congruent to angle S. You can keep adding arcs for whatever your new corresponding congruent parts are, but the other way that you could do it, which I'll exemplify in this last one with angle C, who is congruent to angle N, is you could do an arc with a line through it too. And you can keep adding lines to create new symbols for different corresponding congruent parts. So I'm going to match my symbol here because I know angle C is congruent to angle N. Okay, well, it not only tells us which angles are corresponding and congruent, it also tells us which side lengths are corresponding and congruent. So here, I know that segment AB is congruent, so AB, and for corresponding congruent side lengths, we use tick marks. So I'm going to use one tick mark for AB, which is congruent to SU. Okay. AB is congruent to SU. They have matching symbols. Okay. Notice there are my first two letters here and my first two letters here. Make sure when you write these congruency statements that your order is consistent. All your corresponding parts need to be in the same order. Okay, the next one I have, let's pick a color I haven't used yet. I have BC right here, is congruent and corresponding to UN. So BC is corresponding and congruent to UN. Okay, and finally we have AC, which I kind of go like this. Even though it's not an arc, I'm just showing you that it's my last two letters. So AC, I guess I'll just keep it like that as a little rainbow. Notice this is normally a symbol for arc. I just want to show you that AC is congruent and corresponding to SN. So I'm going to use 3 tick marks for that. Now you can notice that our corresponding congruent side lengths are in between corresponding and congruent angles. So I have red, green in between these, right? Red, orange in between these, and orange, green in between these guys right here. Now the other thing that you might have to do is write out all of the corresponding and congruent parts. So here, I know that angle A is congruent to angle S. So angle A is congruent to angle S. Okay. Angle B is congruent to angle U. Okay. And finally, angle C is congruent to angle N. And we got this all just from this one congruency statement. We can also tell our reader that our corresponding and congruent side lengths are congruent, right? So I can say that AB is congruent to, and notice I have the line over AB. That's because line segments can be congruent. If I don't have that line there, it's referring to the actual length of the line. We don't say that lengths are congruent, we say that the segments itself are congruent because I can do a sequence of transformations that carries one onto the other versus measuring the two and verifying that the lengths are equal. So we say that the segments are congruent. So AB is congruent to SU. And notice how when I'm talking about these lengths or these segments, my order is still consistent. I have AB and SU. Red, orange, okay? So your order matters for everything. This is the hardest part about these kind of proofs because you have to be so consistent. So AB is congruent to SU. Let's see, BC is congruent to UN. And finally, AC is congruent to SN. Okay, so this is the last piece here before we go into an application problem. Now, when we are stating that we know that 2 triangles are congruent, we use what's called Cpctc, or we state what's called Cpctc. It's an abbreviation for corresponding parts of congruent triangles are congruent. So Cpctc, corresponding parts of congruent triangles are congruent. This is basically just shorthand that we'll use. You'll probably use Cpctc when we get to proving that 2 triangles are congruent. This will be your ending statement, and then you can state, let's say, I don't know that all these angles and side lengths are congruent, but I know that this one's congruent, this one's congruent, I know this side. Then once you've proven that, and we'll get into those theorems later, once you've proven that, you can say that these other corresponding side lengths and angle measures are also congruent. Okay, so now let's move on to an example where we're actually using this. All right, so in this example, we are given 2 congruent triangles. So it starts off by giving us a congruency statement that says triangle GHJ is congruent to triangle XYZ. And then we need to find each missing measure. So each missing measure means all of the missing side lengths as well as all of the missing angle measures. So we have our congruency statement. So this actually already tells us which parts are congruent and correspond. So the first thing I'm going to do is label my diagram so I can just visually see which parts correspond and should be congruent. So, based on my congruency statement, angle G is congruent to angle X, so I'm going to go ahead and mark that. We're going to use one arc. Angle G is congruent to angle X. Okay. Now, one thing that I'm noticing before I even start marking this is they gave us these two tick marks right here. And what that means is that this length GH is congruent to this length JH. So actually, a triangle that has a pair of congruent sides just on itself is actually an isosceles triangle. So if this is an isosceles triangle and this triangle is congruent to that one, then they are both going to be isosceles triangles. Now, what's another property of isosceles triangles is what we call the base angles. So the bottom two angles are actually congruent. So I'm going to write that out for you. So base angles of an isosceles triangle are congruent. Okay, so that means this angle is congruent to this angle. So we can use the same symbols there. Notice how these are opposite angles from both of my congruent sides for my base angles. Okay, so I know angle G is congruent to angle X right here. Angle H is congruent to angle Y, H, Y, both my second letters, so H is congruent to Y, okay? And then finally, J is congruent to Z. Well, I know these are congruent, so one arc here and here. J is congruent to Z, so also one arc here. Okay, now let's look at our side lengths, corresponding and congruent side lengths. So GH is congruent to XY, GH is congruent to XY, one tick mark here, one tick mark there. I'm going to match these colors with my blue pen. Okay, and then I have HJ is congruent to YZ, HJ, YZ. These are all congruent, so is this one tick mark. And then finally, GJ, my last two letters, or my beginning and my end letter, GJ is congruent to XZ. So GJ right here, I'm going to do two tick marks, okay, because that's the base of my isosceles triangle. We don't have an equilateral triangle here. GJ is congruent to XZ. Okay, so now that I've identified all of my corresponding congruent parts, I can start actually solving for the missing lengths. So first off, I know that the measure of angle Y is 38 degrees. I also know that the angle H is congruent to angle Y, so they should have the same measure. So the measure of angle H should also be 38 degrees. So we would write that out as measure of angle, M, the little m stands for measure of angle, H equals 38 degrees. Now I could have specified a little bit more and said the measure of angle JHG. Just remember that the vertex needs to be in the middle when you say it that way. But for this, there's no other angle H that I could get confused with, so I could just use angle H. Okay, so measure of angle H is 38 degrees. Now I need to find the measure of angle G, and then once I get one of these, I get all of the rest of them too. Well, we have a theorem that we've used before, and that is that a triangle adds up to 180 degrees. So if these were both x degrees, we would say that x plus 38 is equal to 180 degrees. X plus x is 2x, plus 38 is equal to 180. Subtract 38 from both sides. Okay, so 180 minus 38. So what we could do is minus 40 plus 2. So let's see, 180 minus 40 is 140, but we're adding 2 because we're only actually subtracting 38. So 142, 2x equals 142. Divide both sides by 2. X equals, let's see, 71. So that means the measure of angle G and the measure of angle J and the measure of angle Z and the measure of angle X is all 71 degrees. Okay, so if you need to pause and go through this, I'm actually going to erase my work there just because I want more room to actually write down all of the measures of everything. So, okay, so we know now that the measure of angle G is 71 degrees. We know the measure of angle J is 71 degrees. We know the measure, and I'll actually even write these in here too. We know the measure of angle Z is 71 degrees. And finally, the measure of angle X is 71 degrees. Okay, so we have found all of our missing angle measures. The last thing that we need to do is find our missing side lengths. So I'm going to now erase this, so pause if you need to get any of this down. I'm going to erase this, and we are going to now go and find all of our missing side lengths. Okay, I know that the length of this side is 27 feet, but this is an isosceles triangle. So if this side's 27 feet and this side's congruent to that side, this is also 27 feet. Okay. All right, so we have 27 feet there, but these sides are also congruent to this side. So these are all actually 27 feet. So now let's write this out. So the length of HJ, so we'd write that like this, without the line on top. Remember, the line on top means it's a segment. Without the line means it's the length of HJ. So the length of HJ is 27 feet. The length of ZY is also 27 feet. The length of XY is also 27 feet. Okay. And then finally, I need to find the length of G8 or GJ. So the segment GJ corresponds with ZX. And so corresponding parts of congruent triangles are congruent. So if ZX is 18 feet, then GJ is also 18 feet. So right here is 18 feet. And finally, we can say the length of GJ is 18 feet. So notice for each of these, I was able to solve it because I was using the property of Cpctc. Corresponding parts of congruent triangles are congruent. All right, and that is it for today's video. There will be some more complicated problems that you'll probably come across where you have to set up equations, but everything kind of comes down to the same idea where your corresponding parts of congruent triangles are congruent. All right, that's it.